Number 4 says to use the graph to find each value. All right, so once again, we're thinking about input versus output here. So input is on the x-axis, output is on the y-axis. So when it says g of 9, 9 is the input because it's in place of the x. 9 is the input, so we would look for 9 as the input, and we would see what output does that go with. So we follow that up to the graph, and we can see that the output, if we look over on the y-axis here, that would go with an output of 3. So g of 9 is equal to 3. Input 9, output 3. On the second problem here, we see that the output is 6. So it's on the other side of this equal sign. 6 is the output, which means that we have to work backwards to figure out what the input would be. We would have to work backwards to figure out what x is. So if 6 is the output, we start with 6 on the output side and then follow it over to the graph and then down to see what input that goes with. So output of 6 goes with an input of 4. So g of 4 is equal to 6. We already knew the output was 6. We just figured out the input was 4. So that's all you have to do with those. Just make sure you're keeping track of where the output is and where the input is and follow it over to the graph or up to the graph. All right, number 5 is one of those story problems. As long as your story makes sense with respect to the graph, then you will earn the points for each section. Now this graph is graphing time versus speed. So whatever your statements are making, whatever they're saying, they need to make sense in the time versus speed comparison here. So part A on the graph, and notice that the time is going up, but speed is staying at 0 here. So whatever's happening in our story, it says Jack sat on a bench and laced up his running shoes. So time is going by, but Jack is not speeding up at all. He's maintaining a 0 speed because he's just sitting. Now in part B here, his speed is increasing. So whatever you say in your story, it should make sense that the speed of Jack is increasing. So for instance, maybe Jack is starting to jog. So he's kind of speeding up into a jog. Then in part C on our graph, notice that he's not speeding up anymore. He's maintaining a steady pace. So in this part, whatever you said, he's not speeding up, he's not slowing down, he's maintaining speed. So maybe Jack is jogging at a steady pace. All right, part D. Well, it's going up. Speed is increasing. So speed is increasing again. Now, what does that mean in the story? Well, you can make it up, but whatever you say, it should make sense with the speed increasing. So I might say something like, Jack starts to run. So he's speeding up even more from his jog. However, in part E here, he's slowing down. Speed is decreasing. So Jack slows down to a jog again. This time it's a little bit slower jog because it goes down lower than his previous jog, but nevertheless. In part F, speed stays the same. I guess I said maintaining speed above there in part C, but speed stays the same. So Jack maintains steady jog or jogging pace. You can make it more original if you want and more exciting than this. However, mathematically it has to still make sense. All right, part G, he slows down all the way to 0 again. Notice our speed goes all the way down to 0. So speed decreases to 0. So you might say something like Jack slows down and stops. So at the end, he has completely stopped because it's all the way back down to 0.